This is by DARSHAT SHAH. He's the CTO. Welcome, DARSHAT. The CTO and co-founder of Amaranth Medical Analytics in Bangalore. A computer science engineer by training from IIT Bombay and later at Ohio State University. He worked for a couple of decades at Microsoft on platform development and delivering various products and services. And then moved to the Mazumdar Shaw Oncology Center in Bangalore, where he was a senior research fellow, the area of AI application to healthcare. And in his current position now, he is looking at opportunities in the area of genomics, medical imaging, and digital histopathology. He has this, his focus on, as he says, understanding specific clinicians' requirements and working towards answering specific questions rather than building broad-based products. Welcome, Darshat, and waiting to hear you.
Thank you. Thank you, Dr. Arun and Dr. Sundar, for having me today. And good evening, everyone, and thank you for coming on a Friday evening. So I'm Darshat, and as Dr. Sundar introduced, I come from a background in software development from Microsoft. And then over the last 3 years, my career took a little bit of a turn, and I started getting interested in seeing what can AI do outside its computing origins and in other cross domains like medicine, or I even looked at agriculture, things like that, right? So with that in mind, I spent a couple of years at Mazumdar Shaw Cancer Research Center on the neuro-oncology program, where we were looking at brain tumor analysis using AI. And that convinced me that there is a lot of role for AI to play. And so then me and my PI, we sort of co-founded Amaranth Medical Analytics. The company was registered last October. And so I'm going to describe a little bit of our journey through the last few months in working in the real world beyond research labs, right? So Amaranth focuses on finding biomarkers that can have predictive value. And so we look at genomics, and we also look at imaging. And I'm going to focus this talk on digital pathology, which is basically imaging of cancer tissue, right? It's imaging of tissue, but we focus on cancer. All right, so I'll just start off with this nice vision of AI-assisted clinician's office, and there's like this nice, sweet, sensitive side of AI where, these drones will fly around, offer candy to kids also. And I think that's a good strategy if we want AI adoption to hasten up in medical domain. But we'll leave that for the future. I'll talk more about immediate what's happening in the current world. All right, so why AI and why now? I just wanted to relate a little bit of a personal anecdote here. Middle of last year, somebody in my family was diagnosed with pancreatic cancer. And that biopsy was very disputed. Like, there was one pathologist who was convinced it is adenocarcinoma. In fact, most of the pathologists were convinced it is adenocarcinoma, and one pathologist held out that it is something called non-Hodgkin's lymphoma, or NHL. And so we did another biopsy in another town, in another institution. And again, the findings were inconclusive, and the pathologist couldn't agree on it. And finally, we actually did a third biopsy, which was through endoscopy, not a sonography. Unfortunately, even with that, when we got the tissue samples out, the conclusion was still like controversial, right? But the pathologist was convinced that this is NHL. Like, he looked at the digital slide, he looked at that and said, this is not adenocarcinoma. Now, the reason that is important is because depending on whether it is adenocarcinoma or whether it is NHL, the prognosis is very different. Like with adenocarcinoma, the prognosis is pretty bad and chemotherapy may not even be an option. Whereas with NHL, it is quite good. And there is a very good prognosis if you go for some chemotherapy after that. And so we went with the pathologist who said it is NHL. And long story short, actually that person now is really good. We went through 6 months of chemotherapy, right? So I feel we were super lucky that we got this pathologist who was convinced based on what he saw on the biopsy slide, that all his expertise and the knowledge that he had over the years, he was convinced that this is NHL. And so the question is like, how do we democratize that kind of expertise? Like, how would this be available to everybody? Like, it can't be the case that, like it is today, if you go to one lab, you get one diagnosis. If you went to one other lab, you might get a different diagnosis. And it's a life and death question, kind of, right? So that's one of the things where, you know, if we have automation, we can bring about standardization, we can bring about efficiencies, we can even potentially bring in cost reductions, right? The other angle to AI is that, unlike in the past where there was a lot of hype and nothing really came out of it, now the hardware and software to do this are at a very mature state. We can write application level code that focuses on business logic instead of like setting up the TensorFlow graph and so on, right? Specifically, like if you, I don't know if anybody of you have written a neural net back in the 2014 or 2015 timeframe, and how difficult it was to implement backpropagation or set up the graph and the session and all of that, right? So now it's dead easy. A few lines of PyTorch will put the boilerplate code in place and you have a model ready. And at the same time, the hardware is also super mature. Like you can take an NVIDIA GPU, plug it into your Ubuntu machine, and you're in business. Like, and it can do very sophisticated things, even without going to the cloud. So hardware, software, and I think the third thing, at least in the digital pathology case, is storage, right? We have storage that is fully commoditized, and it is cheap. You can store 25 terabytes in the cloud for a year and pay maybe about 5 lakh rupees, right? And if you're going to put it in archive storage, the cost is about 8 to 10 times less. In some sense, the time is ripe for medicine to adopt digitization and then get the benefit of AI on top of it. So where do we start, right? So first of all, we need digital data. For AI to happen, we need data in place and it has to be gathered and stored, right? And in today's world, if you go and ask around in Manipal or Narayan Hrudayalaya or some of these hospitals here, how many even have a chief information officer? It is very surprising. It is not there, right? The compliance mechanisms that are needed, HIPAA and all of this. In US, it is starting to change. Hospitals are starting to get EHR and all of that adoption. There are protocols for privacy and compliance in place. Here it's changing a little bit slower, right? And then you have data that needs to be digitized, it needs to be anonymized, and put in the right place for variable storage, right? And for the hospitals to take on all this work, they're naturally going to ask, what's in it for me, kind of, right? So that value proposition has to be there, and it's going to be economic. Like there has to be some commercial gain for a hospital to do all of this, right? So like a business deal, how is it going to benefit a hospital or a pathology lab to adopt AI? And it could be a couple of things. It could be that, hey, today a pathologist can do 50 slides a day. And then with the AI assisted mechanism, maybe with prioritization that tells him where to look, he could do maybe 60 slides a day, right? And maybe at the end of the year, that adds up to savings, right? Or it could be something that's patient facing, where you say this AI powered reports are more accurate, and you have to be able to prove that over time. And if you're charging $1,000 for a report, you say, okay, with the AI powered report, I'm going to charge 10% more. But that value proposition has to be there in the real world for hospitals and pathology labs to adopt AI, right? And the last thing, in terms of starting out, and this comes also from my experience in Microsoft, is how do we build multidisciplinary teams, right? So naturally, like doctors and machine learning scientists are not hanging out together on a daily basis, right? It doesn't happen. But if you're going to do an AI startup, they need to be talking together on a daily basis. That we need some kind of a forcing function where everybody is aligned on the same goals. And it's not like, okay, I'm going to go back to my day job, or the machine learning scientist says, oh, I'm going to go to Google and Microsoft, they pay in gold coins. So, okay, the great vision, but I'm gonna do what normally happens. So when we're doing something, this is cross-domain, how do we align and build these teams and align them on the same goals? That is a challenge, actually. And that's a challenge because I was on the other side a few years back, and every year I went to IIT Bombay to hire for Microsoft and machine learning engineers. And now I'm trying to hire them for a startup, and I'm having to compete with the same MNCs. So the talent is there, but there has to be something where they are incentivized. Maybe the social impact of the work is a lot great than, say, clicking on ads or something like that, right? So we need a strategy which sort of brings together multiple kinds of people under the same umbrella. This happens to some extent in research institutions and universities, but there the goals may be different. Maybe it is about getting patents, maybe it's about a PhD, things like that. Whereas in a startup, we need to make money, kind of, right? And so the commercial aspect has to be really, really truly vetted before we go down this path. So now I'll go to some real world issues that we are looking at and what we are doing about it. First problem, gather the data, right? So unlike, like, say, ImageNet or something which exists, Richard mentioned Google has like 300 million image these things that they train their transformers on, for example, right? So unlike that, in the medical domain, data is quite scarce. And annotated good data is even more scarce. So you have TCGA, which is the cancer genomic class, which has a few hundred or few thousand patients, kind of, right? So there are little islands of data here and there. And many a times PhDs are done just on that because it is so hard to find real world data, right? So we really need to focus, and for a startup, this is gold. Like AI startup without real world data would not succeed. So whatever it takes to get the data, if I have to go every month to a radiologist with a USB key, I will do that. If I have to go to a surgery and get the tissue samples, I have done that, right? So whatever it takes to get the data, and sort of sometimes this is also, why would somebody share the data with you, right? So it's often easier if the other side is also interested in the problem. There's somebody inside the healthcare institution who's really interested and who's really convinced that AI is going to help medicine, right? So we look for those kind of strategies and say, we need to have a data strategy in place to get a data stream from the real world, right? Second thing is, once you get the data, how are you going to get the ground truths? And, again, as I mentioned, unlike ImageNet and so on, it is not easy to establish ground truth in the medical domain because regular people cannot do it. This requires expertise, and expertise is expensive, and in many cases, it also tends to be subjective. So sometimes you may have pathologists who will sign up to do this, but pathologists may have different opinions. So you need to have a mechanism to break the tie, right? So the expertise in the medical domain is expensive. They tend to have their day jobs. So what is the strategy by which you're going to have a continuous stream of annotated data that helps you build the models? Second thing is, even if you have data, which data are you going to take to annotate, right? So a WSI image, basically whole slide image, can be very large. It's up to 1 GB and it may be more than 50,000 by 50,000 pixels. So there's no way that somebody can annotate the full slide. It's just impossible. Unfortunately, our neural networks like a fully annotated slide, right? It's a research in progress to make a neural network work on partially annotated data. So the tried and tested mechanisms always require fully annotated data, right? So what is the strategy around that? Like here I've included a little picture here, is we have annotated all the nuclei in this tissue sample, right? Now, this was done through a semi-automated mechanism. So maybe the goal is to spot certain kind of nuclei and then distinguish it from the other nuclei. So instead of having the pathologist annotate each and every nuclei and the positive and the negative samples, we're starting with assuming that everything is a good sample. And then we ask the pathologist to say, you only flip the ones that are having some, they're not background, they are the foreground objects. So we need strategies like that to say, okay, how do we maximize the productivity for whoever is going to annotate this data for us? Third thing, and again, this goes back to my Microsoft experience as well, which is a lot of people are starry-eyed about ML. People come up and tell me, Darshat, I want to join your ML team. And I tell them, dude, this is 99% perspiration and 1% math. Right? So building the ML model is just one small part of the whole thing. Like everything that comes before and after takes a lot of energy, like just starting from the data collection and figuring out what you're going to train, cleansing the data, all of that. Then you build the model, then you set up your pipelines. Pipelines will inevitably they'll break because some data comes which you didn't anticipate. So you have to set up monitoring on the pipelines in the real world, right? And then once the model is ready, it is not easy to just go and drop it out there. Kind of in Microsoft, it would take almost a month to ship a model because you got to ensure that the model is provably better. It may be better than nothing if there was no model in place before, or it is better than the previous model. So you got to do a lot of A/B testing, and you got to do a phased deployment so that it goes out to, say, the first million users, and then the 10 million and 100 million. So in Teams, we had 150 million users to whom we would ship models, but it had to be a very phased controlled deployment, and then we review the numbers every week, and then only let it go to a wider audience. And I can imagine that in the healthcare world, the constraints are even more because the consequences of having a bad model would be really, really bad. And that will sort of create a lot of skepticism and negativity if that happened in the medical domain, right? The second thing in the real world is integration with the medical domain. So unlike e-commerce companies where, in Microsoft and Google, you can quickly ship your models, everything is ready. You have your clouds and everything that are set up for inferencing. In the medical domain, how do I even take the result of an inference and show it to a clinician? And it has to be part of their current systems. We cannot ask them to completely change the way they are doing things. It's going to take a lot of time. And these IT systems may be built on quite legacy code and things like that. So integrating your inferencing or even data collection with the IT systems that are present in hospitals or pathology labs is a real world problem. And you may have to have a strategy around that too. All right, so another problem in the real world, kind of, and this is more around the quality of and quantity of data. There is an ongoing problem called domain adaptation, which means that the data that you get from the real world varies really widely, kind of, right? When you look at histopathology, there is something called H&E staining, which is basically, there are two kinds of stains. There is a hematoxylin, which will stain the nucleus, and eosin that stains the cytoplasm. Now, these stains have to be mixed in a certain proportion and with the right concentration and then applied to the slide. But this is going to vary from institution to institution, right? So in practice, you see a lot of variation in the intensities, in the colors of the data that's coming in. Like, for example, there's a pair of images, and the one on the left is the image that we actually get, right? The one on the right, which is more pink and purple, that is an ideal stain concentration, and that is digitally created. It is not from the real world, but that shows that, hey, the cytoplasm and the tissue is pink and the nuclei are purple, and that's how it should have been. But in the real world, labs and even people who are working in the labs are doing different things. Another example is that of the Sharpie marker that's going across the slide, right? And that's going to kind of really confuse your stain separation procedure, or it might be confusing your NN because it does not expect this kind of stuff in place, right? So you got to sort of work with a very wide variety of data that's coming in the real world. And that's a topic of research, like how do we do this domain adaptation? Then there is data set size. So in histopathology, the images are large. So it's not uncommon that even if you're working on a single model, you will use close to 1 terabyte of space, because the data itself is 1 GB per image. You've got a few hundred patients to work with. You are emitting a lot of debug data also. So you can easily exceed 1 terabyte, kind of, right? So the data set sizes are order of magnitude higher than, say, a little, cat and dog image kind of thing. And you got to set up your file copies and everything else with a lot of thought, because it will take order of magnitude more. Right? Now we have the obvious problem of imbalances. The positive class may be very small. And then finally, the cost. So while storage is cheap, once you start going into terabytes, it'll start adding up. And more than storage, I think a GPU is quite expensive still in the cloud. Like, I had this experience where I turned off the GPU, but I didn't do it the right way. So the GPU was running in the cloud for 3 days over a weekend. And it was a good GPU, so my bill actually exceeded more than 1 lakh just for that, right? So we have to be really careful about things like that. And oftentimes it makes sense to have on-prem machine. If you think that the utilization will be really good, it'll pay for itself quite soon, right? All right, some domain-specific problems. We do a lot of augmentation in regular domains, like if you're doing all this cat and dog stuff and things like that. Now, in the medical domain, this is kind of tricky. We can do augmentation, say, for H&E image by just changing the stain proportions and things like that. But how do I augment an MRI? Like, beyond adding some Gaussian noise or rotating it or something, is there a way I can augment an MRI to generate a very realistic MRI, kind of, right? So now we're starting to see a little bit of that. Like, there's this Monai from NVIDIA that claims to do a little bit of physics behind the scenes of an MRI and will perform certain kinds of augmentations on the MRI, right? For many years, it used to be reversed. Before NNs appeared on the picture, people were trying to standardize the images. So I get a certain H&E image, and I want to make it look like a standard H&E reference. So people were going the other way and saying, I'm going to take it and make it look like it's a standard. And with NN, we have the flexibility to go the other way now and say, oh, I'm going to synthetically generate as much variety as I can, right? So this is also another area of research. Loss functions, obviously we have all this dice loss, and we have the cross entropy loss and things like that. But is there an adaptation that we should do for the medical domain? There are a lot of research papers that come out of this, like the cell boundaries. How do we apply loss functions that compute these boundaries better? Or they will separate out nuclei which are overlapping better, and so on. So that's an active area of research. There's a lot of potential here to do really cool new stuff, right? And that takes into account the medicalness of the problem, kind of. Maybe certain kinds of misclassifications, when you look at it from a biological perspective, they are not as important. And that has to be coded into the mathematics of the loss functions. So that's another area of research. There's another area where we can really push the boundaries. I think Shrikant and Richard talked about federated learning, because not all our institutions are happy to share that data publicly. So there's a lot of research going on how to build ML models where it runs training on each node, and somehow we have sort of an ensemble ML model that doesn't really see the data, but still has the knowledge of how training was done everywhere, kind of, right? What to annotate? How do you make annotation efficient? And how do you annotate things that will make your model the best one possible? Like here, what I mean is, even within a single image, there are so many little sections that you can cut and annotate. So how do you get the best diversity? And there's a lot of research going on in figuring out what should be annotated so that the model sees the most amount of diverse data, right? And then finally, not everything needs deep learning. There's still watershed that needs to happen at times. You'll use OpenCV in many cases, right? So we don't need to use TensorFlow or PyTorch everywhere, kind of. But you have GPUs available. So how do we do the best possible, utilize them in the best possible way? So for example, there is, ports of NumPy to GPU, so that you have something called CuPy, which is coming from the Rapids AI package. And then there are data frames that are GPU enabled. So there's a GPU enabled version of Pandas, things like that. So we got to sort of be ready to adapt and make sure we can do, say, things like texture compute, but utilize the GPU, right? So all that still has a place even in the deep learning world. Okay, some final thoughts. What I've realized is AI in tech is not equal to AI in healthcare. Like the speed at which Microsoft or Amazon or an e-commerce company is going to adopt AI, it's very different. And if it helps them make money faster, they'll gladly put in a new recommender model or something in place, kind of, right? So tech, everybody gets AI, everybody understands the value it's bringing, and it's very, very quick. The processes are set up like that. They're optimized right from the get-go to ship AI and make productivity better for every individual. But in the healthcare world, for good reason, AI adoption is slow. And Richard was mentioning it took like 15 years for a new model to come into practice. So because the consequences of having models that make decisions are much more in the healthcare world. Even when there is commercial gain, healthcare needs, accountability, it needs explainability. So AI, in my view, is never going to replace anybody in the healthcare domain. I think it's only going to assist and make them more efficient and maybe bring in portability and, cost reductions and things like that. So the speed of iteration is less and the bar on accuracy is super duper high. Like, unlike in the tech world, we can say, okay, I'm going to find an operating point that emphasizes on precision, and I'm okay with a little less recall, or the other way around. But I can't do that in the medical world. Like both the sensitivity and specificity have to be super duper high, right? So we have to be really, really good models that will not sacrifice one for the other. So that is a big challenge. But those challenges are going to be met. There's so much work happening now in this field. It's exploding. New papers are coming out every day. So I think AI in medicine is here to stay. It is an exciting new frontier. There's a lot to be done. And I think it has a lot of potential to have a lot of societal impact, especially in a country like India, where if we can democratize it and we can make the results of this reach, little villages. Like when we were doing Mazumdar Shah, we had an optical device that would take a picture of the mouth cavity. And then we had a very good model based on that would predict whether there is any lesion. And if there is a lesion, is it benign or malignant? And imagine that if we could do this in the real world, where somebody can just take a picture of their mouth cavity and upload it. Then they don't have to visit the district center or something to come in for testing. So just it speeds up the process, makes it a lot more democratized. It makes a lot of costs go away, kind of, right? So I am very convinced that AI in healthcare has a huge role to play. We just need to figure out the right strategy by which we put it in place. Okay, so with that, I will conclude my talk. Thank you for listening, and I have a little call out that we are hiring. But if you have questions, I'm happy to answer.
Thank you, Darshat. There are some very important messages from your presentation, and quite impressive the way you stepped back and forth between the world of technology and your interaction with the clinical world. Just checking questions. Yeah, these for this question. Yeah, I have a question before. Oh yeah, we have a question already from Anant, who was our speaker yesterday. He works with computer vision and machine learning in the area of surgical technology.
Okay.
I have the same opinion that domain adaptation is a serious challenge, especially in transfer learning and medical applications. How serious was your challenge in the pathology domain?
So I will say this is not past, it is still serious. It is a serious challenge. Just within Mazumdar Shah, we saw a variety of differently scanned images. Like just the focus is sometimes missing, or sometimes there is, if it's a frozen slide, you see water artifacts on the image. So it is a very serious challenge, in my opinion. And we have to be able to train the NNs to do the right thing. And I miss talking about this, but sometimes we also, and this is an area of research in this NN space, that we need a measure of confidence as well from the neural net. Because if I have trained the NN and then I feed it something it has never seen before, it will give me some output, but I really need a number to go with it and figure out how confident it is of that output. So that is actually a pretty serious challenge, and we need ways to either augment or come up with a confidence measure that helps us overcome this problem, right? And the more data we get, the better, actually. The wide diversity always helps.
There's another question before that. Amazing insights, thanks. Can you talk a little about how you might put some processes in place for getting data and annotating them?
So I'll be to the point. You have to incentivize people for it, right? See, this is expertise that is expensive. They have day jobs. So if you want this to happen in a consistent way, there has to be some strategy to it. So one of the pathology lab chains we are partnering with, they actually said that this is great, but another benefit that we hadn't thought about, but they were actually very well sold on, was that when you scan the slide, it makes it very easy to collaborate among the pathologists. Like literally today, you have to courier the slides from one pathologist to another if they have to get a second opinion, kind of. Or if you are trying to show what is on the slide to somebody else, this pathologist, he actually had a little adapter for an iPhone that is stuck on his microscope, and then he would put his iPhone on it, and then he would take a picture, right? And then when we said, look, this you can actually zoom into this image, and it has a nice navigation to it, and you can put some annotation on it and put your comment on it, and then you have a web server that is exposing it to the real world, so anybody can, anybody or somebody, you're permitted somebody to look at it. That made the process of collaboration between pathologists a lot simpler, and that incentivized them, right? So we need something like that. So sometimes we think that our models are super duper, and I have a hammer and I'm looking for a nail. But then when we talk to pathologists, we ask them, what are your problems that we could help with? And along the way, then we sort of have a mutually beneficial or a symbiotic relationship, kind of, right? And it is always possible to do something for them and say, let's start up a common project that will help you or make your subjectivity a little bit less, or things like that. So those are some of the things we can do to sort of get more buy-in from the medical side.
Question, Darshat. How different is the annotation problem or issue between medical imaging, say CT, MR, etc., versus pathology, histopathology? Is it different?
It is somewhat different. I think there's a difference in resolution for one. Like, so the MRs tend to be like 240 cross 240 cross 155, and you're done. It's a 3D volume. Whereas in the case of digital, the WSI images, they are 2D, but they are super large. So that's one big difference. 2D versus 3D and the size difference. And then the tools are different. So we had to put up our own front-end server to do annotation efficiently, because you need to allow zoom. Like, for example, if you use Java, you cannot even load such a big array. So you have to use special zoom mechanisms to, zoom into certain parts of the image and annotate it. On the other side, actually, I'm not aware of a web-based way to do annotations, but there are tools like ITK Snap or MITK that allow to do annotation. But as far as I know, these are confined to the desktop unless somebody has done a web-based version of it. So they do tend to be different.
Thank you. Any further questions for Darshat? Yeah, there's one. Do startups in this space collaborate on data? For instance, Path AI works to build similar models, I believe.
Yes, I think there are a bunch of startups in the space. But unfortunately, I do not know too much about this. I know there are startups in Bangalore itself that are in various phases of incubation, but there isn't a good umbrella right now to bring along common discussion on that front. So yeah, I actually don't have a very good answer to that question. But would be lovely to actually collaborate and talk with people who are in that space. That would be super useful.
Another question, how long did it take for you to set up data acquisition pipeline? And how do you think universities can start establishing this? There are some open data sets, but are they representative enough for tackling real world problems in pathology?
Yeah, that's a great question. I mean, when I was hiring, I look at the PhD students who, especially in the last couple of years, because of COVID, the whole data gathering exercise has slowed down like big time, kind of, right? And so many people are doing their thesis on TCGA or some of these publicly available data sets. So that's sad. I'm hoping that now those pipelines will start becoming, easier to establish. It depends. I think it depends, as I said, on the interest from the other side and what they feel they are getting out of this. Like when I was in Mazumdar-Shaw, I used to go with a USB stick to the radiologist to gather data, kind of, right? And we met once a month, but sometimes they are busy and we miss our appointments, and then it takes another time to set up that appointment again. And so it wasn't a very structured process. The pathology lab chain we are working with, it is a little bit more structured, and they push a few GB to the cloud every day, kind of, right? So that has been more smooth. I think it depends on who you're working with and how incentivized they feel to be part of this whole journey, kind of. So as I said, I think that strategy has to be there somehow, and it's not a technical strategy. It's something that you just have to figure out what is in it for them to participate with you, right?
I think there are no further questions. Thank you, Darshat. It's been a wonderful interaction. And I just have an announcement for students who attended these webinars and who have intention to participate in the AI for Healthcare program here at IIT, they can reach out anytime to me. I'm V.K. Sundararaman and Professor Arun. Our numbers, our contact numbers are on the flyers you received for the webinar. So we look forward to hearing from you. Thank you all very much and good night.
Thank you, Dr. Sundar. Thank you, Dr. Arun.
Thank you. Bye.